Hello everybody, my name is Isaac Andron. My team members were Blake Venable and Craig Martin. For this project we looked at hydrogen fuel cells. And the first thing I want to do to introduce you to the project, to talk a little bit about why we care about hydrogen fuel cells. Firstly, they're a renewable energy source. They're also environmentally friendly and they produce clean water as an emission. They were used on the space shuttle and extremely high efficiency is possible. I also want to talk a little bit about the history of the fuel cell. Christian Friedrich Schonben was the first guy to actually come up with the idea of a fuel cell in 1838. He was a German chemist. It wasn't until a year later a guy named William Robert Grove, who was an English barrister, actually demonstrated the technology for the first time. And I have a picture up here of Grove and his fuel cell that he came up with. And it wasn't until 120 years later that we actually got the first practical application of the hydrogen fuel cell. So for 120 years, they were just kind of this weird thing that nobody knew what to do with until all of a sudden NASA used it in Project Gemini in 1965, which was a precursor to the Apollo program. So I think that's really neat. More recently, Toyota released the Toyota Mirai, which is the first production hydrogen fuel cell vehicle. So there are a lot of different types of hydrogen fuel cells. I'm not going to really go through all of them right now, but the one that we used for this experiment was the proton exchange membrane, or PEM. And so there's this schematic here of the PEM fuel cell, and it's pretty detailed, and it's got all this this nice schematic here, and you can take some time to read that if you'd like. But I'm actually going to explain it with this animation that I think is a little more clear, a little. Well, I like it better anyway. So you can see here hydrogen is coming in from the left side, from the tank. At the left catalyst, which is the cathode, it is generating some electrons and then kind of using them back up to form water with oxygen from the air. And so those electrons are going through and forming a circuit. So that's the basic process. On to the methodology. So we used some things for our experimental apparatus. We used a Pascal 850 universal interface, which was used to measure the voltage and the amperage produced by the hydrogen fuel cell. But to get things started, we have to generate the hydrogen with an electrolysis stage, and we used a DC power supply to add the power in. So this is our basic setup. And so I'm going to go through it left to right to give you an idea of how it worked and what we did. So on the far left side, you can kind of hardly see it, but it's a solar panel. We didn't actually end up using that. We ended up using the DC power source instead because it was cloudy on the day of the experiment. But on the just to the right of that, you can see a clear cylindrical water tank, and that is where we start with the process. And so what happens is this next kind of clear rectangle thing, that's actually a hydrogen fuel cell, but it's doing what we call electrolysis, which is the kind of the opposite of what we expect a hydrogen fuel cell to do. It's working in reverse, taking in water and electricity. It's using up electricity to generate hydrogen. And so this thing in the middle here is the actual storage mechanism for the hydrogen. And then you see another hydrogen fuel cell that is doing what we expect of a fuel cell, which is to take in hydrogen and generate electricity and water as an exhaust. And then on the far right, you can see a small electric fan. You can kind of see the motor. The fan itself is spinning, so it's kind of hard to see. And so the basic experimental process here was to measure how long and at what voltage and amperage it took to generate a certain amount of hydrogen. I believe it was 10 centimeter cubed. And then we measured how long it takes to use up that same amount of hydrogen using the universal interface to measure at what voltage and amperage we were producing power. And once we have all that information, we can actually find out what is the efficiency of this whole system here. So to the results, we have the average current out, the average voltage out, the total time that it took to use up all that hydrogen. And then on the right table, you can see the average current going in and the average voltage going in and the time that it took to generate that hydrogen. So we can use these two equations I have here in the bottom left, that power is equals to voltage times amperage, that the energy is equal to the power times the time. So we can do some math here and get those numbers, and then we can actually find the efficiency. Of course, the efficiency is the energy out over the energy in, and we expect to lose some due to loss. And so when we do that calculation, we find that the efficiency was about 27.1%, which is pretty low for a hydrogen fuel cell. Actually, this is the lab scale, just for demonstration type fuel cell. But professional industrial quality hydrogen fuel cells generally can attain sometimes over 80% efficiency. So they're a very efficient power storage mechanism. So the applications of something like this, one is of course the Toyota Mirai I talked about earlier, but I don't really think that that is a good application for the current hydrogen fuel cell technology. See, the limiting factor is really the storing and moving around the hydrogen fuel tanks. These are extremely expensive fuel tanks. They're a little bit complicated to refuel. So I don't really expect to see anytime soon going to the gas station and having to choose, between gasoline, diesel, and hydrogen. I think that's a little farther off. But, a better vision for a hydrogen fuel cell of today, I think, where they could really shine, is in a power plant, like the one you see here. This is kind of a smaller unit power plant. And the basic idea with this is, so you have a renewable energy source, such as a solar cell, for example, that's going to take in solar energy during the day, but then at nighttime, what do? So you could use extra energy during the day to generate hydrogen with that electrolysis step, like in our experiment. And at nighttime, use up that hydrogen with the fuel cell and power your home through the night. This is way more efficient than using something like a lithium-ion battery or, any of the more common power storage mechanisms we have. So here are some of my references. And thank you for listening. If you have any questions, you can leave it in the comments, and I'll try to get to them.